Okay, so my apologies. I'm not able to be in school today. Hopefully you'd already heard me and I warned you that I wasn't going to be in school today. I will be checking your homework that was due today, next class period, which I believe is Friday. So I believe I will see you tomorrow. What we're doing today is the first of the absolute value lessons. There's 2 of them. Today we're working on the graphs of absolute values. So what you see in front of you is the page that you need to find for your warm-up. So go find that page in your pink packet, pause the video, take a few minutes, try and do the warm-up, and then come back to the video and I'll go over how to do each one of these 4 problems. All right, so on the first box, it says to graph both of the functions on the same axis. So we can kind of take an easy way here. We can say, okay, we know the y-intercept is 4, and we know the slope is 2. So let's plot a point at the y-intercept of 4. And for the slope of 2, I'm going to go rise 2 and run 1. And I ran out of space for that pattern, so I'm just going to return the pattern in the opposite direction and keep going the same way until I cover the whole piece of graph paper. And then I can go ahead and I can connect that with a nice straight edge. Okay, making sure I go all the way through the graph paper. Now, I'm going to have to put 2 equations on the same graph. So I'm just going to label this one y1 so I can tell the difference, and that way I don't have to write the whole equation. Okay, for my second one, it looks like my y-intercept is at -3, so I'm going to put a point at -3. It looks like my slope is -2/3, so that means I'm going to go down 2 and then over 3. So down 2 and over 1, 2, 3. And down 2 and over 3. And again, I run out of graph paper, so I reverse and continue the pattern in the opposite direction. And I go ahead and I connect with a smooth line all the way through the graph paper, and I go ahead and I label this y2. We put this as a y2, and now we have both on the piece of graph paper. That's all I wanted you to do there, just some practice graphing. What is the restricted domain for each? So in the second box, what we need to remember is that we are not able, for the first 2, we are not able to divide by 0. So we're not allowed to have 2x plus 3 equals 0. So we're actually going to write that 2x plus 3 does not equal 0. Okay, because we cannot divide by 0. So now we solve this just like this was an equal sign, but instead of having an equal sign there, we're going to have that not equal to sign. So I'm going to subtract 3 from both sides. So 2x does not equal -3. Then I'm going to divide both sides by 2, so x does not equal -3/2. That is the only value, basically. I can have all real numbers except for -3/2. That is the only number I'm not allowed to substitute into this function, because if I do, what will happen is it will make the bottom of this fraction 0, and 2 over 0 is undefined. So we're going to do the same thing for the second one. The second one is x squared minus 49, and it cannot equal 0. So I'm going to add 49 to both sides. So x squared cannot equal 49. And the way we undo squaring something is to take the square root of both sides. So that would get me x does not equal positive or -7. You have to include both of those because we took the square root of both sides. So basically, if I substituted in +7, I would have 49 minus 49. And if I substituted in -7, I would have 49 minus 49. Both of those would get me a denominator that was equal to 0. This last one's slightly different because it's not talking about a fraction. What we have here is actually a square root. We are allowed to take square roots of positive numbers right now, and we are allowed to take square roots of 0. The question of square root is what number multiplied by itself equals whatever's under the radical sign. So if I'm looking for the square root of 9, what number multiplied by itself equals 9? So the answer would be 3 or -3. But the problem is Like I can do the square root of 0 because 0 times 0 equals 0. It has an answer for that. But if I were to say take the square root of -9, what number multiplied by itself would equal -9? Well, no number multiplied by itself would ever equal a negative, because if we had two positives multiplied together, that would be positive, and two negatives multiplied together would be positive. So basically, our rule that we're following for this one is that 2x, oops, I want to switch colors here, I'm sorry, so that we see a different problem, is that 2x minus 8 must be greater than or equal to 0. Can't be negative. That's how we would write that. So we're going to solve this inequality. Add 8 to both sides, so 2x needs to be greater than or equal to 8. Notice as I'm doing all of these, I'm recopying the sign I started with. Divide both sides by 2, so x has to be greater than or equal to 4. Anything smaller than 4 would cause the value under this radical sign to be negative, which we cannot, as of right now, do. Okay, so let's look at the bottom two boxes. So this box down here we're looking at a summer job pay, and it looks like these are the numbers of hours that are worked, and this is how much they get paid in dollars on their paycheck. So they're trudging along, 10 hours in, they get paid this much, 20 hours in, they get paid this much, and you can see it's pretty constant. But then all of a sudden when we hit this 40-hour mark, the rate of pay, or the slope of the line basically, the rate of pay increases. See how the slope was pretty solid here, but then all of a sudden it got greater. It became a more positively sloped line. What could have caused that to happen? Well, a lot of times, once you hit a 40-hour work week, right, that's a normal work week. So you're actually working overtime. So over 40 hours would be overtime, which gets paid more. A lot of times it's like time and a half or something like that. Okay, now what we need to do in this second box down here is that we need to look for these values. We need to be able to read a graph, basically. Okay, so what it's asking us for in this case, it's saying the pay function at what our x variable is, which is hours in this case. So we're looking for the pay at the 20th hour. So if I go over to my graph and I read it, I have to approximate right about there. That looks like it's going to be at about $150, I'm guessing. Okay, as long as your approximation is close, it's fine. If I go over here and approximate my pay at about 40, it looks like it's below that $300 line. So I might put 280 or 275. Anything around that will get you the correct answer because we don't have a function to substitute it into right now. So if I go to the hour number 50 for this third one and I go up and I read the pay, it looks like it's just above the 500 mark, so maybe $520. Now, if when you're reading a graph, and I'm just going to use this as an example. So if when I'm reading a graph, I have a line that comes up to here, right? And it has an open circle right there. And then it has a closed circle up here and a line there. What I'm going to do is I'm going to go and read this until I hit the solid mark. So basically this open circle, I'm going to pass right through that open circle until I hit that solid mark. So if I were to, this brownish graph, whatever color this is, if I were to say what is the value at 50, I would say, okay, 50, and I would come up here to that 200. It would not be at 100, it would be at 200. So that's just a note for the future. All right, the next thing I want you to go take a look at is these 6 graphs, okay? The stuff in between that you have right there, you can actually, let's go through and look at these real quick. So these pages that are in between the warm-up and the next thing we're going to do, we're going to put some X's on some things because you don't have to do them. All right, so we're going to start with this 3x3 page, which I think you already put an X on. See how we have 3 equations, 3 variables. We don't need to do that one. We don't need to do that one. And we're putting an X on it because I don't even want you to look at it while you're studying for your test. Okay, so we just did this drill. This is a 3 variable also, so we don't need to do that one. And then I had piecewise functions in here, but the county says we don't need to do piecewise functions, so we're not going to do these parts. Okay, so just follow along in your papers and put X's through the same ones. I'm crossing off. We will not be graphing piecewise functions. Okay, so we're crossing this one off. This was a homework assignment. We're crossing that off. This was the rest of that assignment. This one, and I think that, yep, that brings us to where we are now. So I want you to take a look at these 6 graphs and remember what it means to be even and odd. And I want you to write whether the graph that you're looking at is even, odd, or neither. So you can take the video and pause it for a second and then come back and I'll go over and explain why it is even, odd, or neither. All right, so to be an even graph, you must have reflective symmetry. And very specifically, it has to be reflective over the y-axis. And it has to go through the point 0, 0. To be an odd graph, it has to have rotation symmetry. And not just rotation, but rotation of 180 degrees. And it also has to go through the point 0, 0. So looking at, oops, didn't mean for that to come open. So looking at this very first graph, I see reflection symmetry over the y-axis. Looks the same on both sides. And it does go through the point 0, 0. So I'm going to call this graph even. This graph right here, it looks like if I turn the graph completely upside down, it will look exactly the same as when I started. So it has rotation symmetry of 180 and it goes through the point 0, 0. So this one is odd. This graph right here has reflection symmetry over the y-axis, but it does not go through the point 0, 0. So this one is going to be neither. Neither or neither, however you say it. This graph also has reflection symmetry over the y-axis, but it does not go through the point 0, 0, so it is neither. All right, now this graph here, very interesting graph I've got here, because yes, it goes through the point 0, 0, so we know it could be either one of these. If I reflect this over the y-axis, that means then the graph would come up like this, so that's not true. But if I flip this graph completely upside down, this point would come down here. The point that's below the x-axis would come here above the x-axis. So it does have rotational symmetry, so it is odd. And the last one we have here going through the point 0, 0, again, I could rotate this graph, turn it upside down, and it would have rotational symmetry of 180 degrees, so it would be odd. So next in your packet, you have 2 graphs. One is the shape of a V and one is the shape of a downward facing parabola. I want you to go through both of those graphs and identify the pieces, the characteristics of each one of those using this information. Remember what the minimum and the maximum mean, what it means to increase and decrease. So you're going to do both of those graphs and then come back to the video and see if you got it right. So pause now and come back when you're ready. All right, so our first graph here, it's a V. We're going to see a lot of these today, actually. The domain being all of the x values. It looks like it covers the entire x-axis. So I'm going to say x is equal to all real numbers for the domain. The range looks like, remember, if there's no dots here, that means that there's arrows, so they keep going. So the range in this case goes down to 1, 2, 3, 4. It goes down to -4. But it doesn't go past that. It's everything above or equal to -4. So we're going to say y is greater than or equal to -4. you're either you could have both minimums and maximums, but in the graphs we're working with, you're either going to see a minimum or a maximum, basically. And it looks like our minimum point is right here. That's the vertex of this graph. It does not have a maximum, so we're going to write none here. The minimum point is going to be at 1, -4. Increasing and decrease has to do with whether it's going uphill or downhill. So as we start over here, it looks like it's going downhill to start. So it's going downhill and downhill and downhill and downhill. And it stops going downhill once the x value reaches 1. So the whole time x is less than 1, it's going downhill. And then once it hits 1, it turns around and it starts going uphill again. So it is, I read that backwards. I gave you decreasing first. And afterwards, it's increasing after the 1. So it's increasing when x is greater than 1. End behavior is that weird statement where all you have to do is fill in the very last piece of it. And it will always say this part. As x approaches infinity, y approaches what? You have to fill in the blank now. So as we go further and further this way and we're reaching to infinity, what are my y values doing? My y values look like they're increasing. And they're going to keep increasing forever and ever. And so that means they're heading to positive infinity. Okay. Then the other way we go, as x approaches negative infinity. So now we come this direction. So we come all the way over here to negative infinity. What are my y values doing? Well, again, it looks like it's getting larger and larger and larger. And it will until it reaches positive infinity again. Is this graph even, odd, or neither? Well, right now, it looks like it doesn't go through 0, 0. That's usually the first test I do because I can eliminate a lot of graphs that way. So I'm going to say neither. It looked like it might be an even graph because it looked like it could be reflective, but it doesn't go through 0, 0, and it's actually not reflective over the y-axis. So let's look at the second one, the parabola that opens down. This one, again, no endpoints, so it looks like it goes on forever that way. So the domain looks like x is equal to all real numbers. And the range, well, my top number is at 2, 4, 6, 8, 10, 12, 14, 16. So my y's are going to be less than or equal to 16. I do not have a minimum here, so I'm going to write none. Or I guess you could write negative infinity because it does go down to negative infinity. But my maximum is at the vertex, which is 0, 16. This graph is going uphill all the way until x is 0. So that's for when x's are less than 0. And then once it hits 0 and goes beyond, it starts decreasing. So that's when your x's are greater than 0. And as x approaches infinity, so as we go this way, what's my y value doing? Oh, it's getting smaller and smaller and smaller. So it's approaching negative infinity. And as x approaches negative infinity, what's y doing? So as we go this way, again, y is getting smaller and smaller. So y is approaching negative infinity. This graph looks like it could be even because it's reflective over the y-axis, but it does not go through the point 0, 0. So it is neither. N-E-I-T-H-E-R. Okay, so now we actually wanted to get into the lesson for today, basically. What we're working with today, and anytime I'm going a little bit too fast, you've got the advantage right now, you can pause me. Okay, go finish what you're writing and then come back. So what we're working on today is at the absolute value function and graphing them and knowing their characteristics and being able to recognize the equation for an absolute value. This is the equation for an absolute value. That h and that k right there are going to be huge for us along with the a. But the h and the k are going to be huge because that's going to be something that we see in every graph from this point on in this course. All right, so let's go ahead and check out our first situation here. We just kind of want to check out what happens when we start putting numbers into certain places in that equation, okay? So first things first, I want you to graph the equation that is the parent function the absolute value of x. Okay, so this is what you're graphing right now. You can go to Desmos and you can graph it. Oops, I lost my mouse here. There we go. So we're graphing y equals the absolute value of x. Now, some people don't really understand absolute value. What these bars basically are telling you to do is to tell me what is the distance of the thing inside from the number 0. So for instance, up here, the number 3. How far away from 0 is the number 3? Well, it's here, and 0 is here, so it's 1, 2, 3 boxes away. So that's your absolute value. 6, the number 6 from 0 is 1, 2, 3, 4, 5, 6 boxes away. That seems pretty basic, like, so what? But then we get into these things inside that are negative, and it says, how far away is the number -4? Well, it is 1, 2, 3, 4 boxes away from the number 0. Where is the number 2? It is 1, 2 boxes away from the number 0. Some people get confused and think it's the opposite of what it's inside or whatever. Basically, because we're talking about distance, what happens is, and this is the cheat that you can use, anything that's inside is the distance of something. So when you bring it outside the absolute value bars, it becomes the positive. So if it started positive, it stayed positive, like this 3. But if it started negative, it became positive on the outside. So I'm going to graph this in Desmos, but real quick, I'm going to graph these points here. So I'm going to make x be the 3 that we put in, and y is the 3 we got out. X is the 6 we put in, and y is the 6 we got out. Here, we put in -4 and got out +4. Here we put in -2 and got out +2. So I'm going to go ahead and graph those points. So 3, 3, 6, 6, -4, 4, and -2, 2. So you can see it's already kind of taken shape. Let's go ahead and double check by looking at the graph real quick. Okay, so you can see here I have graphed y equals the absolute value of x. If you're looking for those absolute value bars on your keyboard, it's right up above the A, B, C button. So it's this one right here. See the absolute value bars right there? So that is your absolute value bars. You have to open it and you have to close it. Okay, I already have some other graphs in here that we're going to use in a few minutes. But let me close that back down and let's go up and look. You can see I have y equals the absolute value of x. It is actually a v, because what's happening is if we put in 5, we get out 5. But if we put in -5, we also get out +5. So it's actually taking the thing that was the line, y equals x, and kind of bending it up to this quadrant here. Okay? So going back, if I graph the y equals the absolute value of x, I should be using a straight edge here if I'm at home or in the classroom with my pen and my paper. That is the absolute value of x. I'm going to save here and come back and work on a second video for the changes that happen. So there'll be a video right after.